on the chat. There are links to the notes, so try to get those open while you have the chance, because this is the first question in our notes this morning. All right, that's a little better. So let's officially say that, yeah, during a thunderstorm, if we're in our normal kind of laws of physics reality, then we should see the lightning first, okay? And then explaining why, it is because light travels faster than sound. Light travels faster than sound. We made the same mistake. So yeah, no beef on you guys, all right? We made the same mistake. Light travels faster than sound. Again, if the lightning is closer to you, like one time during a thunderstorm, I have to remember being like only like 20 yards away from a lightning strike. And if you're that close, of course, from your perception, they're happening at the same time. But the farther it is away, right, the more noticeable the difference is. All right, so this is going to be our answers for number 2. Again, seeing lightning happens first, and it's because light travels faster than sound. All right, we tried to fix that there. Hopefully we didn't confuse anyone too much. All right, and be sure to raise your hands for the notes and for number 2. Moving on from there, awesome. So just some reminders this morning, guys. Please don't share any personal information during class. All right, your participation is always required, and we are recording these sessions for learning purposes. All right, what we're getting into today is that we're going to talk about color, right? Why do we see color? Why does color even exist? Right, the light that comes from maybe the light in your room or from the sun, right? It doesn't obviously have a color to it, but everything, whether we know or not, has some sort of color, and we are going to study why that is the case. All right, so in terms of our unit and our lessons, this is going to be the second to last lesson in Unit 4 for waves. And then on Monday, we're going to come back and talk about refraction of probably light waves and see how that works. There we go.
This is a reminder that your last STAR 360 assessments are next week on Tuesday and Wednesday. So you will be doing reading in period 2, whatever your normal period 2 class is on Tuesday, and then math in whatever your normal class is on Wednesday during period 3. These are worth 5% of your overall grade in every single class, even science, history, PE, tech, and careers. So really important that you get those done. That way you can get a little bit of a boost in every single class to your grade. Originally, we did have an exam on the same day as STAR 360, so to prevent that, we're going straight from Unit 4 to Unit 5, and then we will be combining the Unit 4 and 5 exam into one exam here on Wednesday. We won't be zeroing it out until Thursday, so you have a little bit of a grace period there. And then after that, you have 1 week until Wednesday, June 9th, which is the last day of the school year, in order to get anything done, specifically the Unit 1 airplane project, the Unit 2 drop project, and the Unit 3 roller coaster project, as well as the Units 4 through 5 exam. Those are worth 70% of your grade overall. They're each worth, what is that? 70 divided by 4, 17.5% of your grade, which means that it's impossible to pass without them. Like literally impossible. If you're not doing projects and exams, you're wasting your time trying to get stuff done. That's not going to help your grade. Okay. Tell me in the chat really quickly, what time do courses close on this Wednesday? Important for us to know, what time do courses close on this Wednesday? Last minute that you can turn something in. After that point, there are no extensions. It is the last day of school. There won't be any extensions because we have a very quick turnaround for grading. Thank you, Itati. Thank you, Cody. Yeah, 11:59 p.m., which means 1 minute before midnight. 11:59 p.m. And so that means you have all 24 hours on Wednesday to get stuff done. But after midnight on Wednesday, you will no longer be able to submit anything. You will no longer have access to anything. That is the last, most final deadline. Yep, June 9th is your last day. So you have 1 week from your final exam from your last exam to the end of the trimester. Okay, so you can use that week to catch up on stuff. This is a reminder that this is my last day with you all. So I will be leaving at 4 p.m. today, and I will not be back for the rest of trimester 3. So thank you for being my students this trimester. I do still have office hours today, though, if you did want any help with any leftover project stuff. Again, the sub that is coming in tentatively right now is actually coming from like an English background, so they might not be as helpful with science stuff. So I would recommend if you do need help with projects even after I leave, please reach out to Mr. Bangle, okay? Just because he knows, he's very familiar with with what's going on in the course, obviously, and he has that science background. So please make sure you're reaching out to him, especially as we're kind of shuffling subs and stuff around. So again, though, I would recommend just get them all done today. So come to office hours if you need help figuring out what to do. Get those projects submitted.
All right, so today we're going to specifically being defining transmission, the terms transmission, absorption, reflection, and refraction of light. And we're going to explain how reflection is related to seeing colors of objects. All right, so it's very, very interesting stuff. All right, yeah, we already got our notes out, so let's move on from there to our brainstorm. So our brainstorm this morning is pretty simple. So light travels really fast, right? We already know that. But how do we stop light? Give me some ideas in the chat. How do we stop light? It has an actually like a fairly simple explanation. Yeah, you put a wall in front of it, you close your eyes. Solutions, maybe I can hear a couple more. Again, it's all the same concept, but there's multiple ways you can accomplish this. Really doesn't have to do maybe this doesn't apply to the physics for this lesson, but what if we're talking about the picture, right? If we want to stop the light from a light bulb, what's a creative way we can stop the light from coming from the light bulb? Yeah, we can cover it. Yeah. I was trying to be creative and say, well, we can just turn off the light switch, right? We can in other words, we can cut off its power supply. All right. Just reminding everyone that light isn't infinite. Like there's no infinite source of light. Even the sun has an energy supply that's running off of that will eventually run out in like millions of years from now. All right, but all good answers. So yeah, we can cover it up or we can block it. All right, so for example, light travels millions of miles from the sun only to be stopped by your own body, resulting in a shadow, right? So we're going to learn that there's multiple different objects or pieces of matter that can block light or can reflect light, right? Such as a window where the light actually travels through it, but is bent at a slightly different angle.
Okay, so let's talk about the four main ways in which light interacts with matter. So, light being the electromagnetic waves, matter being physical substances, right? Light's not something that's physical, but it can interact with physical substances. So, the first one is transmission. So, transmission's really easy. Transmission is just when light goes through a substance. So, it can go through matter without changing anything. So, for example, you can see light through air. So you can see right here, just transmission means to go straight through. Okay, so this is our example right here. This is number one. Okay, then you could also have absorption. So absorption should remind you a lot of the word absorbs. And so when you absorb something, that means that you're taking it in and you're keeping it. Okay, think about if you put lotion on your skin and your skin absorbs the lotion is staying on your skin. Smiley faces emojis in the chat if that makes sense. So absorption means it gets absorbed into the matter. Okay, now once it gets absorbed into the matter, it actually converts to a different type of energy, mainly heat energy. So absorption generally results in heat buildup. Okay, heat buildup. So, for example, as air absorbs light, because air also absorbs some of the light, not just transmits, but also absorbs, that is why air begins to warm up. So, as the sun comes through, not only can we see through the air because of that light transmission, but also the air gets warmer because the light is also being absorbed a little bit into the air. So both things are going on. Now, reflection is bouncing. Okay, so reflection, think about if you are reflecting something back, right? That's going to be bouncing. So this is when light bounces off of a matter surface. So, for example, air can actually also bounce air off, can also bounce light off on of it, which is why the Earth actually glows, right? So, without light coming off of the Earth from the sun, so it goes from the sun to the Earth, then bounces off the Earth, you would not actually be able to see the sun from outer space. Okay, go ahead and give me a green check, orange checks if that makes sense. So, if light did not reflect off the Earth at all, the Earth would be dark if you observed it from outer space. Okay. Awesome. All right. So yeah, so some light also bounces off of the air atmosphere so that you can see the Earth. And then lastly, some light rays also refract in air. So refraction means bending. So this is important to understand. Reflection, think about how a mirror reflects exactly what you see, right? Exactly what's happening. So that's why reflection is just bouncing straight back. All right. Refraction, though, on the other hand, just means it's bending a little bit as it goes through. So refraction, light bends a little bit as it goes through matter. Air refracts light, and this actually changes the color of the sky. So again, transmission straight through. Absorption, think about it's absorbing and building up as heat. Reflection, think about how a mirror bounces your image back. So reflection, light rays bounce back. And refraction, that's our last one, kind of maybe the least familiar one. That one is just when light bends. So let's take a look at this in action. So we can see here, again, light coming in and bouncing off of a surface is reflection. Light coming in and being absorbed into a surface and turning into heat, that's absorption. And light going straight through a substance, that is transmission. And again, a lot of substances do both things, right? So you can see here that a window, when sunlight comes in, some of it goes through the window, but some of it also reflects off. That's why you can see your reflection in a mirror, because the light is actually bouncing off so that you can see yourself in the mirror. Okay? Now, this one again, refraction, we're going to learn a lot about refraction on Monday, but refraction is actually when light bends. Now, interestingly enough, in the atmosphere is mostly made up of nitrogen with a little bit of oxygen, and nitrogen specifically scatters blue light the most. So the light from the sun is made up of all the colors of the rainbow, but when it hits our atmosphere, all right, the nitrogen in our atmosphere mostly makes the blue light bend a little bit more, and that is why the sky is actually blue. So if you've always asked yourself, why is the sky blue? It is because it's made up of nitrogen, and because the sunlight is bouncing off of the nitrogen, mainly the blue rays are bouncing off, and so that's why you see a lot of blue in the sun. Okay, go ahead and one more time, give me a smiley, medium, sad face if you're feeling good with these different terms here. We're going to practice it in just a moment, so I want to make sure we feel confident. Excellent. All right, let's go ahead and try this question. If my slides will let me move, here we go.
These terms using our thin lines like usual. All right, good. Mallory's up there. So let's go ahead and go over it. For our terms, so absorption is when light converts to different energy, all right? It's not when light bounces off matter. It's not when light bends, all right? Absorption is when it converts to a different energy, all right? That's kind of the process of how color is forming. Yeah. And then reflection is when light bounces off matter, and then refraction is when it bends right through matter, kind of like a window. And then finally, transmission is when light goes through matter. Please raise your hands for number 3 when you're ready to move on. All right, so let's review visible light for a second right here. So color is part of the electromagnetic spectrum, right? That's the spectrum that we said that all wavelengths of light are a part of, right? And there's that narrow band in the center where it is composed of visible light, and it's split up into these many, many colors. All right, these are only EM waves we can actually see, right? Where at the extremes of this spectrum, where beyond red is the infrared spectrum and beyond violet is ultraviolet. That's kind of like the tail ends of what we can observe. And then the colors actually correspond to different wavelengths. So a short wavelength results in a high frequency or high energy. So that's why violet being closer to ultraviolet light is very, very high energy in terms of what we can see. Long wavelength results in a low frequency and low energy. So the more waves that can happen in the same span of time, the higher energy it is. All right. So for number 4, let's go ahead and mark down the word visible in our notes and raise our hands for number 4 as well.
Excellent. All right, so let's go ahead and talk a little bit about this. So, how many of you have ever seen a prism before? Go ahead and give me a smiley face or a yes or a no in the chat. How many of you have ever seen a prism? Yeah, so they're super cool. I actually have one at home. Obviously, I'm not outside though, so it doesn't work very well indoors. But you can see a prism is a like triangle shaped piece of glass. Now, prisms are super fun to play with. They're actually not even that expensive either. So if you ever have a little bit of extra cash, go on Amazon or wherever and get a small one for yourself because they're fun to play with. My daughter loves to play with it. But a prism is a wedge-shaped glass, and its purpose is to split white light into its separate colors, specifically the colors of the rainbow. All right, so you can see a picture of it right here. We're going to go over it and see a GIF of it in just a moment. But what you can see is white light comes in, which is the light from the sun. And as that light comes in, remember white light is actually a combination of all the different colors. And so as it goes in here, it actually begins to refract or bend, right? We learned that term earlier today. And as it refracts, the colors begin to separate. Now let's talk about why that happens. So normally in a vacuum, in the air, in outer space, right? Wavelengths generally travel at the same speed, or at least not at a speed that we can distinguish them being very different. All right, in air, wavelengths travel a little bit differently, but again, not enough for us to really notice, except for in the sky with nitrogen. However, once light enters a prism, it becomes very obvious. Each wavelength begins to travel at different speeds. Okay. Now, normally, the speed of light is always the same for everything, right? For every type of electromagnetic radiation. But once it enters a prism, there is a change in speed, and this results in bending. So specifically, violet waves, which we saw on the previous slide, are much shorter and happen a lot more. So as that violet light tries to get through the glass, it interacts a lot more with the prism and slows down, right? So this is like if you're trying to jog through sand and you're trying to do zigzags through the sand, you're going to slow down a lot more than someone who just goes a much straighter path. Go ahead and give me a green check, orange X if that's beginning to make sense. So the violet waves zigzag way more, so the result is they get slowed down. Okay, so they're going to bend the most, whereas red waves bend the least because they are much longer. They just kind of go in a straighter pathway, in comparison at least, and so the result is they bend the least. So what we can see here is we end up with red on top, which is bending the least, and violet on the bottom, which is bending the most, and every color in between. Now, I know it's hard to kind of visualize that from just a picture, so let's go ahead and show you a GIF. All right, I'm going to go ahead and share this with you up on the board. Go ahead and give me a smiley face in the chat if you can see the board up here. Smiley face in the chat if you can see the board up here. Yes, it's rainbow colors. All right, perfect. Looks like we're able to see it now. Beautiful. All right, so taking a look here. Again, we can see white light coming in, which is just the regular light from the sun. And as it interacts with this prism, again, you can see those purple waves, or you could say photons, are much closer together. So again, they're interacting so much more with the prism that they get slowed down a bunch, and so they bend a bunch. That's why they end up on the bottom. The red one, though, almost takes a straight path. The red one is like, all right, I'm a much longer wave. I don't interact as much with the material. And so I'm going to go a little bit straighter. I don't bend as much. And so the red one ends up on top. And every color in between follows that same pattern. Yeah, the yellow one also has longer wavelengths, and so it doesn't bend quite as much. Blue, though, is almost as short as purple, and so blue bends a lot. All right, go ahead and give me a smiley medium sad face if that visual makes it make a little bit more sense. Awesome. I see lots of smileys. There we go. Benjamin, thank you. Kai, smiley medium sad face. Jaime, Matthew, Juan Carlos, Jayland, Alicia, Brianna, Callie.
I wonder what the green one means.
Yeah, the green one is in the middle. Green one's in the middle, has a medium size wave. All right, so let's go ahead and jump back over then and take a look at what we've got. All right, so taking a look here, go ahead and fill in for number 5, right? We start out with white light, and then remember that violet, because it interacts so much with the prism, slows the most. So slowing right here. You do not need to capitalize, but you do need to spell it correctly.
I wonder what green means.
Go ahead and take 40 seconds to fill that out and raise your hands. Okay, so let's talk about the color of objects. So here's the deal. We've been talking about transmission, absorption. We've been talking about reflection, refraction. Now, when we have opaque objects means you cannot see through them. So that means there's no transmission of light, right? Because if you could see through them, there would be transmission of light. So opaque objects do not transmit light. Instead, they reflect light. And this reflection of light is actually where color comes from. So this is important to understand, that color is not a property of an object by itself. It's actually how objects interact with light to produce color. Because if there's no light, all objects are what color? If there is no light, all objects are what color? Tell me in the chat. No, if there's no light, no light. Think about it, if you turn off all the lights in your house, everything looks like it's what color? Tell me in the chat. Yeah, everything appears black, all right? So without light, there is no color. So in order to have color, you need both the object and the light. No light, no color. Taking a look here, what you can see here is, for example, this leaf has white light coming in. Okay, and it's going to absorb some of the light rays, all right, and it'll reflect some of the light rays. In this case, it's reflecting green light, and as it reflects green light, that's what hits our eyes, and so this is why it appears green. Not because it's absorbing green, but because it's actually not absorbing green. It's actually reflecting the green into your eyes. Go ahead and give me a green check, orange X if that's beginning to make sense. We're going to practice it a whole bunch. Let me know if you understand that. Perfect. Green checks again. The color that gets reflected is the one that you see for an object. Excellent. All right, let's go ahead and try it out here. Okay, this is going to be number 7. Go ahead and fill in the blank with the word reflecting. Again, capitalization does not matter, but spelling does. 25 seconds. Raise your hands. All right, so let's go ahead and practice this. So what I want to know is which ball here is reflecting the most light. Go ahead and tell me in the chat, which of these 3 balls do you notice the most light is bouncing off? Is it the black one, the red one, or the white one? Where do you see light being reflected or bouncing the most? Yeah, exactly. We can see it right here, right? Absolutely. All of the colors here are bouncing off, right? So this is the white ball. And since all the colors are bouncing off, that's why it appears white, because all those colors combined together make white. So tell me, if all of the colors are bouncing off, do you think that this ball will stay cool or get hot? If it's not absorbing anything, everything's bouncing off or reflecting, is it going to stay cool or get hot? Yeah, exactly. It's going to stay cool. Absolutely. This is why, for example, they recommend that in the summer you wear light colors, colors that are closer to white, because more light will bounce off of them and so you will stay cooler. Now, on the other hand, which ball absorbs the most light? Tell me in the chat. I know that I experience this every summer because of my hair color. What color absorbs the most light? Yeah, absolutely. The black ball is absorbing the most light. We can see that none of those light rays are bouncing off. They're all going into the ball, so they're all being absorbed right here. So therefore, go ahead and box for me on the on the board. What will happen? Will this ball stay cool or get hot? Go ahead and box the correct answer on the board for me. Yeah, absolutely. You're going to get a lot hotter in the summer. So I agree. I do wear a lot of black. I tend not to wear very much white, but I definitely pay for it in the summer because I do get warmer in the summer. This is going to be the answer to number 8 and number 9. Make sure you check off both things, right? So the white ball will stay cool for number 8, and the black ball will absorb light and get hot for number 9. This is going to go ahead and be 30 seconds for 8 and 9. Raise your hands. All right, let's go ahead and practice these. So tell me, based on this diagram that we see up here, what color do you see? Again, the color you see is the one that gets reflected. So go ahead and tell me in the chat, what color should we see? What color should we see? Awesome. I see Joseph and Cody in the chat. What color? She's giving you all the answers. Come on. Yeah, you would end up seeing orange. Absolutely. This is the one that is being bounced off right here. So that's the color that we see. Every other color gets absorbed, right? So red, yellow, green, blue, and violet, RGB in this case, would all be absorbed. All right, this is going to be number 10. All right, the color you would see for this one would be orange. Go ahead and take 10 seconds to do that one. Should be a fast one, and raise your hands. We're going to fly through these because I know we're almost out of time. All right, what about this one? What color will we see here? Again, think about reflection. What color is being reflected? Don't tell them. Don't tell them. What color? Yes, I see Jonathan, Joseph, Cody. Yes, blue is being reflected. Absolutely. All the other colors are being absorbed. Those will turn into heat. So Roy G. V. Roy G. V. Excellent. This is number 11. Raise your hands. 10 seconds. All right, this one might be a little bit trickier. What color do you see? What is being reflected? What color do you see here? Think about what is being reflected here. Yes, Cody is right. There's nothing being reflected, so nothing means what? Nothing means what? What color will I see then? No, again, think about if you have no light, like at nighttime, what color is everything?
Black.
Yes. Nothing being reflected would be black. This means everything else is being absorbed, right? So all the colors are being absorbed, which again is why black is so much hotter during the summer. All right, this is number 12. Go ahead and take 10 seconds to do that one.
Or I should say, what color, since they're all reflecting, what are we seeing that's being reflected? All right, yeah, that's going to be white. Can I get a little more participation in the chat? Exactly, white. So what colors are there any of them? No, yeah, it's going to be none, right? All right, so for this one, it's going to be white, all reflected, and none are being absorbed for number 13. So complete on your own. So we have some colors are being absorbed, some are being reflected. Answer on your own, what color do you see and what is being absorbed? Today we were able to learn about transmission, absorption, reflection, and refraction. All right, we learned all about the colors and what it means when some reflect and when some absorb, and what that means we see and how that affects observed color. All right, if you'd like to go ahead and let us know how you feel about this lesson, just really quickly here before we wrap up.